I'm Jennifer Gomez. I'm a postdoctoral researcher at Radboud University in Nijmegen, the Netherlands. As a postdoctoral fellow, I use solid-state NMR to study materials, which are really relevant for industry, for normal materials that are used in normal life, as for example, as screens or batteries or solar panels. So it's quite interesting to use this nice tool to understand the structure of different materials that we use every day. Most of the materials I study contain quadrupolar nuclei. So quadrupolar nuclei are most of the atoms in the periodic table. And the problem with quadrupolar nuclei is that the resolution and the sensitivity is no good at lower fields. So when we go to higher fields and when we have access to this nice new 1.2 gigahertz, the sensitivity is increased, the resolution is increased, and we can resolve better the signals that spectrometers like the 400 cannot do. So we can get insight into the more detailed structural details of the materials. I work with zeolites, that are the materials I mentioned that are present in detergents, that are used as catalysts for the refining companies, that are used for ion exchange materials. These that we use every day, the structures are not well resolved, and the current magnets that like 400 megahertz cannot give detailed information of the structure. So spectrometers like the 1.2 gigahertz actually allowed us to see very detailed how is this structure and how we can extrapolate this to improve the properties of them. Coming back to the same materials I was mentioning, the researchers, our collaborators, have certain assumptions of how the material was. And now when we were able to record good spectra with better resolution and sensitivity, then we observed that we have actually more signals that they were expecting for. So, and that translates that the way they were synthesizing this material maybe was not the right one. So now with these new results, we need to rethink, or they need to rethink in a better way to synthesize them. So that drastically changed procedures and how to improve the materials, essentially. That's a really good question, because sometimes people think we do rocket science, right? And for example, one of my neighbors, I was explaining that I'm a researcher at the university and I study the structure, so I give him examples like the materials I can use can help you to the solar panels you have in your home. So the information I can get in the laboratory can help to understand the material and to make it improve, that you have better solar panels in your home. So it's really interesting that people think, oh, these 8, 10, 12 hours you spend in the lab actually can help us in daily life and how we can improve a material. So that is really fascinating when you can put them in terms that they can understand. So every time they see me, they say, you are working in solar panels, you will make them better. So I say, yes, I will make them better. No, in that way, but for them it's something they can understand. The material are composed of really tiny atoms, and then we need like a specific, I will relate it like a specific magnifier glass. Then we can really see in detail these small atoms in the structure, and then sometimes the way the materials are done is not the perfect way. They have some vacancies, they have some defects, and all these different defects can affect how the material performs. So if we are able to understand if a material has defects or have different vacancies, then we can help to improve the material. So I always tell people that are not related with NMR that is like if you have a radio at your home. So these different atoms have a different frequency, like when you select the frequency in a radio. So if today you want to see aluminum, then you change the frequency in your radio and you see aluminum. If this material also has oxygen, then you just change the frequency, and today we observe oxygen. So for them, it's really nice with one equipment we can see different frequencies of different radio stations, as I used to tell them.